Hello everyone. So today I was just solving this LeetCode problem, and I thought like it's it's a simple problem, but due to the nature of operation they have mentioned, I think it will confuse many people. So yeah, we have this problem where I can show you here. Yep. Can I close this? Nope. Okay. So the problem states that it has given us a array of elements. Okay, some a1, a2, a3, blah 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 blah, with some an elements, and we have to convert all the elements to one. Okay, that's our goal. Now, in order to convert it, okay, like it has asked like you can only perform this operation. Okay, which is like select an index I and replace either the element itself or the next element with the GCD value. Okay, so yeah, so for example, if I have a2, a3, a4, let's say I have a1 here, so I can collect their GCD, a2, a3. Okay, and I can either replace a2 with G, or I can replace A3 with G. So yeah, and the uh, question basically demands us to give the minimum number of operation to make all the elements to one. Okay, and if we cannot do it at all, then we will return -1. Okay, now if we go through this test case like 2, 6, 3, 4. Okay, so here we can easily observe that these two are like the GCD of these two numbers, like they are adjacent, so the GCD will be 1. Okay, so I can replace, let's say so yeah, GCD of 3 and 4 will be 1, so I can replace either 4 with 1 or 3 with 1. So let's do for let's replace 4 with 1. Okay, so operation count 1, I replace this, rest everything is same. Now we can see, like if I try to find GCD of this, then it will become 3 and 3. If I try to find GCD of this, it will become 2 and 2. Okay, but I already have 1 here, right? So the optimal strategy will be to use this one and convert 3 to 1 by performing a GCD over this. Now this will convert to this. Now I can use this one to convert this 6 to 1. Okay, 1 1 1, this. Okay, and finally I can convert this 2 to 1. Okay, using this one. Okay, so 1 1 1. So we can see like we have a progressive number of operations. So finally I'm doing 4 operations. Okay, in order to convert this whole array to 1. Okay, so do I have something else? Yeah, we have a eraser. Cool, let's increase the size. Not increasing. Oh, I can put a number, so let's put, okay, let's put to 40. Oh, I can create a new board. Okay, I'll check on that. Cool. Now let's look at this test case, which is 2 10 6 and 14. Now if I look at any adjacent pair, I cannot find any one of them to be giving me 1. Okay, and yep, so if I go pairwise, nobody is giving me 1. Okay, and in order to verify whether this can be my answer, I can take the GCD of the whole array. Okay, and this will give me 2. So the overall GCD of the array is not 1, which means I cannot convert it at all to all ones, so I can simply return -1 here. Okay, now let's look at another interesting case, which is let's look at 5 15 30 and 16. Okay, now in this case, if I look at all the adjacent element, okay, this guy will give me a GCD of 5. This guy will give me a GCD of again 5. Now this guy will give me a GCD of 2. Okay, now in our first run we are not finding anything, anyone here. Okay, but if we take the whole GCD, okay, I'm getting 1, which means there is some subarray where I can convert, that's like one of the element in that subarray to 1. Okay, so there is a hidden subarray here where I can get my 1. Okay, now if we look at this segment, okay, so here if I take the whole GCD, okay, essentially what will happen, so I have 15, 30 and 16. Okay, so if I do a GCD over that, it will give me 5 and 5, then 16. Now if I do a GCD over not yeah like 15 and 16, now if I do a GCD between these two elements, okay, this will give me 1. Okay, then I can convert either this to 1 or this to 1. Okay, then I can use this one to convert this to. Okay, so yeah, so our task is to find a subarray that can generate a 1. Okay, now if we have an array that can like where the overall GCD is 1, so that is a subarray, it satisfies the condition. But in order to minimize our number of operations, okay, it's best to get a shorter subarray. Okay, so one way you can think is, so I can do the same thing, okay, 5, 15, 30, 16, and I can progressively replace all this element with their GCD value. So for example, I did 5 and 15. Okay, I convert this, I take this 5, but I replace this 15 with the GCD of 5 and 15, which is 5. Okay, then I have 30 and 16. Okay, so I can take this 5 and 30 and convert this 30 to 5. Okay, so it will look like 5, 5, 16. Then I can take this 5 and convert my 16. Okay, so basically I can take this 5 and take this 16 and perform a GCD over it, which will result in 1. Okay, then I can make this 16 to 1. Okay, so here 5 and 15, here 5 and 30, here 5 and 16. Okay, then I have 5, 5, 5 here. So yeah, this will work. Okay, but if we look at the number of operations, okay, I have to go from first till the last to get my 1. Then I have to use that 1 to convert these elements to 1. Okay, so in order to get from here to here, okay, I will take around like let's say there are n elements. Okay, I will take around n minus 1 operation to get my 1. Okay, then I have to use this 1 to convert all the past elements to 1, which is again n minus 1 elements. So it's like 2 times n minus 1 elements. Okay, so here if you see, so from here to here we reach till here in 3 steps. Okay, then I need again 3 steps to convert this to this. Okay, then I have to use this to this. Okay, 5, 5, and I have to use this, so 1, 1, 1, then I have to use this and this, so I will convert it to 1, 1, 1. So yeah, so eventually I will reach this, but I'm taking more number of steps. But if I simply start from here to here, okay, so let's see how many steps I took here. Okay, so 5, so here I only took 2 steps. Okay, now I have to repeat this 2 steps here. Okay, so let's do it again maybe. Okay, so 5, 5, 5. Okay, I take 15 and 30. Okay, converted this 30 to 5. Then I use 5 and 16 and converted this to 1. Okay, so till here 2 steps done. Okay, now I will use this one to convert this and this. Okay, so yeah, this to this. So 1 1 15 5. Okay, then I can use this 1 and 15. Okay, and convert this and 5. Then I can use this 1 and 5 pair and convert this 5 to 1. So 1 1 1 1. Okay, so in our previous approach we took around here 3 and here 3, so 6 steps. Okay, now if I look at here I took 2 steps here. Okay, and 3 steps here. Okay, which is 5 steps. Okay, so yeah, so that's the overall logic. So we have to find my kind of shortest subarray. Okay, where I can get my first one. Then once I got the one, I will simply replace all the elements with that one, like by performing this GCD operation. Okay, so yeah, to simplify this, you can think of like once I find this, okay, I'll take this len. Okay, so this is this len is my shortest subarray where I can get one. Okay, now in order to convert all the elements in this len to 1, I will need len minus 1 operation. Okay, and in order to get my first one, I will take len minus 1 operation. So it's like 2 times len minus 1 operation to convert all the element in my shortest subarray to 1. Okay, then whatever elements are remaining, okay, I can simply add them to my number of operations. Cool. So I hope you guys get the logic, so we can code it. So first of all, yeah, one more case we can deal with, like let's say my array has 1 already. Okay, so I can use that 1 and convert rest of the elements to 1. Okay, so first I need to get the count of ones. So I can say ones equal to count of nums begin nums end. I need to get the count of ones. Okay, now if ones is greater than 0, okay, then I can simply return nums minus ones. So for example, let's say I have 3 elements and 2 of them are ones. Okay, so I just need one operation to convert this guy to 1, right, using any of the 1. Cool. So this is our first case. Then if we do not have ones, okay, so we are in some cases like this. Okay, then I need to find my shortest subarray. Okay, so for that, first let's capture the len of nums. Okay, then let's create a shortest subarray length. Okay, some variable. Let's stick to n plus 1. Okay, I can use int max or something. Okay, but yeah, this guy will carry my length of my shortest subarray. Okay, then I will simply iterate over all the subarrays. Okay, so for int I equal to 0, I less than n, I plus plus, then for int j equal to I plus 1, n, j plus plus, I stick to prefix. Yeah. And yeah, so this will give me 2 pointers in my array. Okay, and then I will simply iterate over all those elements. Okay, and yeah, before that I need to get a running GCD variable. So let's call it let's start with the first element itself in the subarray. Okay, now I can use the inbuilt function of GCD to calculate it. Otherwise I can create my own GCD function. So we can create our own GCD function. So let's start with GCD. Let's implement a lambda function a int b and returns int. Okay, then I can say if b equal to 0, I will return a. Otherwise I will I need the self loop here. I'll call self of b with a mod b. Okay, so this is the standard GCD code, we can use it. Cool. Now I will check if in my current subarray I can get my 1, okay, by continuously performing the GCD. Okay, so for k, let's start with I. We have to start with I. So k less than equal to j plus plus k, g equal to GCD of g and nums of k. Okay, and yeah, so now finally I need to check if I get a 1. Okay, then I can update my sublen to a minimum of sublen plus the length of this. Let's capture the length somewhere here. If yeah, so int len, yeah, int len equal to j minus I. So these are the number of elements in my current subarray. Now if I get a GCD equal to 1, so I will simply update my sublen with this len. Okay, cool. Now after all this subarray iteration, if I didn't get any subarray where I can get my 1, okay, so then my sublen will be still n plus 1. If it's still n plus 1, then yeah, I can simply return minus 1. Okay, otherwise if I got a subarray, then I can say what is the remaining number of elements that I need to update. Okay, so that will be basically n minus sublen. Okay, then I will check in order to get my 1. Okay, and yeah, so and convert all the elements in that subarray to 1. Okay, how many operations I need. Okay, so that will be 2 times of like what we discussed here, 2 times of sublen minus 1. Okay, so yeah, this is the number of operation that will be required to convert all the elements in my shortest subarray to ones. Okay, then once all the elements in this subarray are ones, whatever remaining elements I have, I can simply iterate over them and convert them to ones. Okay, so my final answer will be remaining plus the number of operations. Cool. Fingers crossed, it should work. Let's see. Aha. Oh yeah, it should be nums. I can bring this guy up here and I can say n minus this. Taking time, should be j I j k. I have this guy. Oh yeah, I need to pass GCD here also. Self here. I could have used the normal GCD function, that should be easy. Yeah, why I'm doing this? Okay, fine, it worked. Let's submit. Cool. We got the top percentile, but yeah, I don't care. I don't think this is good because I'm using lambda and lambdas are slow. Okay, because it just increase in your stack space. So yeah, guys, please avoid using lambda. Just for this quick DSA question you can use it, but yeah, avoid using lambda. Okay, now let's switch to other language. Let's try in Golang. Okay, the concepts are same. Okay, whatever we implemented in C++, let's implement in Golang. So yeah, what we did, so first we count the number of ones that we have. Okay, and before that we collected the number of elements we have. Okay, so I will say n is number of elements. Then I can say in order to get the count of ones, I have to iterate over all the elements. So le in range of nums, if le equal to 1, I will increase my ones count. Okay, now if I got ones count more than 0, then what will I do? I will simply return nums minus ones. Okay, like the same code that we did here. Okay, then if once is still 0, then I need to find my hidden subarray. Okay, So I can create the same stuff, which is sublen. I will initialize to n+1. Okay, then I need to iterate over all the subarray 0 and there is only post increment happening in Golang, so yeah, there is no pre increments. Like that's why, like, in some way C++ is cool, I can say. But yeah, I think this is for safety reasons. Then yeah, cool I plus 1, j less than n, j plus plus. And yeah, I need to create my GCD. So let's create a anonymous function, GCD func, and it takes a b int and returns a int. Okay, let's define it as this. If for b not equal to 0, I will be replacing a and b with b and b with a mod b. Okay, and finally I'll be returning a. Cool, so this guy is done. Then cool, so similarly what we did here, so we will first initialize our GCD. Okay, I can bring this guy to here. Cool, so G will carry the nums of I. Okay, then I will iterate over all the elements in the subarray for k from I, while k is equal to j, then k plus plus. Okay, I will say G equal to GCD of G and nums of k. Cool with cool. Okay, so then I will say if I got G equal to 1, okay, then I can say sublen equal to min of sublen with the len attribute. Okay, yeah, we could have done one more optimization here. Okay, I could have neglected also. If my len got updated, I could have avoided all the unnecessary subarrays which are more than len. Okay, I could have avoided that. So yeah, I can do it here. So let's say my len is j minus I plus 1. Okay, now if my sublen is shorter than my current len, okay, I can do a continue. Cool, so this will prevent me to look so if I got a subarray, okay, which can give me my 1, okay, and that subarray's length is lesser than whatever subarray am I going to iterate, okay, I will simply avoid that. Cool, so here G nums k. Okay, sublen this, I will replace this with len. Okay, and this will update my sublen. Cool, then same stuff. So if sublen equal to n plus 1, I will simply return -1. Otherwise I will say remaining elements are n minus sublen. Okay, and the number of operation I need to convert all the elements in that subarray to 1, which is 2 times sublen -1. Okay, we can also see there is some relation. Okay, I don't need to do like rem plus ops. I can see so rem is my n minus sublen. Okay, so I can say n minus sublen plus I'm doing 2 times of sublen -1. Okay, now if I simplify this expression, so it will be n plus sublen -2. Okay, so yeah, this should work. So I can remove these 2 lines. Okay, and I can say n plus sublen -2. Phew, okay, I repeated the same stuff n minus 1s. Cool, let's submit this. I'm the only one. Oh, cool. Now just the final stuff. Let's try with Rust, because I'm learning Rust, so I thought like it will be a good exercise to do it in Rust. Okay, so I will implement my GCD here, GCD, and it takes in32a and in32b, okay, and it returns and in32, okay. Same definition, if b equal to 0, I will return a. Otherwise I will call this guy again, so I need to use this self keyword to call it again. So I will replace a with b and b with a mod b, okay. Yeah, should be good. Cool. Now here also let's count the number of ones, and before that let's get the count of nums. So nums dot len, and here let's get the count of ones. Ones will be I can do nums iter, so iterating over all the pointers of the elements. Then I can do a filter over them, okay, and I can write a lambda which is all the elements that are present here. Now if that element is equal to 1, simply count that. Cool. Now if I say if count is more than 0, okay, I can simply return now this will be u size, this will be u size, and it expects i32, so I can do something like n as i32 minus 1 as i32, okay. Cool. Then the next part, which is sublen, so I can say sublen, and this will be a mutable variable because yeah, this will get updated, right? So I will start with n plus 1 here. Okay, so now my sublen is a u size. Cool. Like here the data type will be u size, and yeah, let's iterate over all the elements. And yeah, so for I in range 0 to n, okay, and for j in range 0 to no, I plus 1 to n, okay. Then I need to create my g variable which will carry the running GCD, and this will be this will be what, nums of I. Cool. Now I will iterate over the subarray. Let's use k in range I. I need j also, so equal to let's iterate over it. I'll say g equal to self colon GCD of g with the nums of k. Cool. Yeah, and if g is equal to 1, I will simply update my sublen, okay. Now the bad thing about Rust is they do not have this max and min function, okay, but they have it on the variable itself, and I don't get the intuition of this, okay. So I need to call my min like this, which I don't like. So I'll say j minus I plus 1, okay. I can add this len stuff here to ignore all the subarrays. If I got a sublen, yeah, so similar stuff what we did here, okay. I can do it. I should do it. Yeah, I should do it. Why I'm lazy? Yeah, let's do it. So I'll say len, which is g minus I plus 1, okay. Now if my sublen is less than my len, I can continue from that, okay. Otherwise I will simply update this. Otherwise I will go through all this. Cool. So this is done. Now I will say if sublen equal to n plus 1, okay. If I didn't get any subarray, I will say return minus 1. Otherwise I can do this stuff. So return n minus n plus sublen minus 2, okay. Now these two are u size, so I need to convert them into i32. So let's convert them to as i32, and let's convert this guy also. Cool. Fingers crossed, should work. If it doesn't work, I have to fix it. It should work. It it worked. It worked. Peace. Cool. Three languages. But yeah, the code is very similar to what I wrote in C++. So I'm not sure this is the optimal way to write it, but yeah, I just wrote it and it passed, and yeah, I got the top percentile chart, but I will not trust it. Cool. So I hope you guys I hope I cleared the concept behind this question, and you guys learn something new. Okay. Uh, so yeah, see you guys on some next videos, and please do like and subscribe if you found this video helpful. Cool. Bye bye.